What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. In this video, we are looking at part 7 of our Pandas tutorial series in the Python programming language. And without any further ado, let's get to it. So, to kickstart this session off, we are going to talk now about dropping entries from an axis. Okay, so this is what we start this session off with. Now, you guys know, right, we've dealt with series as well as data frames. So majority or most, if not all, of the operations that can be performed on a series can be performed on a data frame object as well. So first things first, guys, go ahead, import pandas as pd. Okay, next, go ahead, guys, create this object. It's a pd.series object. For this series, suppose we'd also like to utilize numpy as well. So numpy as np. We'll do numpy.arange 5. For the index for this specific series, since we are having 5 values, we shall provide 5 indices for this series. So we'll keep it simple: A, B, C, D, and E. So that is that. If you'd like to view this object, this is what we obtain. That is fine. Now, the focus for this specific cell of code is dropping entries from an axis. So now, dropping, in case you are new to the terminology, drop is the same as delete or remove. Okay, we are taking it out of that specific entity. In our case, we are taking it out of the series object. So there's a built-in method for this. What we will do is, let's create now the new object is equals to the original series object, which is obj dot drop. And what exactly are we dropping? We need to pass in the label, in other words, the index of the row that we'd like to drop. So suppose now in this little series that we see here, I'd like to drop the third row, which is basically having the index of C. All I'd have to do is object dot drop, and I'd provide in a string format, or depending on what your index is, you'd basically provide that value of the index to the drop function. Now, if I print the new object to the screen, new object, you guys are going to see that C is missing. Okay, so that's what we obtain. And I should mention that it's not necessary for you to keep assigning a new object, and then storing that dropped version in it. I just set up a new object here just to show you guys that it is possible, right? So for example, let's take the new object, and this time let's drop maybe E. So you can have it as such. See, E is gone from this, but this is not what the new object is. This is just in an instantaneous runtime. So that is fine. Now, you guys understand that. That is excellent. The next question you are likely to have is, what if I need to drop multiple, indices or rows from my series? How do I do this? So to do that, all you have to do, so let's do new object 2 is equals to the original object dot drop, and in a list representation, you should pass all the indices that you'd like to drop. So I just want you guys to view the original object quickly. So this is the original object. Now suppose from that object we'd like to drop the last two, so D and E. Now when I print new object 2, you guys are going to see there are only 3 records in our series. Why? Because this is exactly what the drop function will do. We dropped the indices D and E, hence those rows were completely removed from the series object. So that is good. Now it is obvious now what we just did, that the concept of dropping entries from a certain axis, we just did it on a series, right? so it can be applied to a data frame as well. I'd like to demonstrate this for you guys. So create this data frame with me. Go ahead, import numpy and pandas. So import pandas as pd, import numpy as np. Now what you'd like to do is just set up a data frame is equals to pd.dataFrame. Within this we shall pass numpy.arange. We should pass 16, and we'll reshape this array to be a 4 by 4 array, 4 by 4. Now that is the data for the data frame. Next, what you'd like to do is the index itself. The index is what's going to be found on the extreme left axis. So it's the indexer column, right? What we'll do here, guys, we'll make it the names of places. So let's do Ohio, let's do Colorado, let's do Utah, and let's do New York. So New York, that's fine. Now the third parameter we'd like to use is the columns parameter. We shall provide names for the columns. Let us do a simple column name. So 1, 2, 3, and 4. That's what we have. If you guys would like to view this data frame, you may go ahead and do so. It looks like this. So we have this 4 by 4 data frame. That's fine. Now how do we drop certain values from the data frame? Now it is very important for me to tell you this, right? That there are two, as we have done with series, but it is not, entirely noticeable with series because of the fact that you work with a 1D array. With the data frame, it is noticeable. Now you see the concept of dropping values according to a specific axis. Now there are two axes that exist even in a data frame, right? Those two axes is your row axis and your column axis. The row and the column axis make up the axes that we have for the data frame. Now oftentimes you will find a number, just this is, you see, for parameters, when you are working with the parameters, instead of specifying row and column in words, oftentimes you'll see them specified as numbers, and we will look at this. Don't stress about this. As I mentioned before, it is always good to know what to expect in advance, okay, with regards to certain parameters and their names. So this is just you and I getting introduced to how the row and the column axis are actually represented. Row is usually represented by a numerical value of 0, and column is represented by a numerical value of 1. So keep that in mind, okay? We will really use that at a later stage. Now, suppose I'd like to create a new data frame object. This data frame object is going to be set equal to the original data frame object that has all the following values that are dropped. It is going to be dropped along the row axis, which is basically 0. As you can see, the axis here is defaulted to 0. So what I'll do is, according to the row axis, which is basically the indexer column here, I can delete any one of these rows that I'd like. For demonstration purposes, suppose we are deleting Colorado as well as Ohio. Now, when we print data frame 2 to the screen, instead of having 4 rows of information, it is only going to have 2 rows of information because we just deleted 2. Okay, 2 of those rows. So that's fine. Now, this is the interesting part. What if you'd like to, delete certain values according to the column axis? The column basically axis is equals to 1. By default, it drops according to rows. So if we want to delete according to the columns, there's 2 ways you can do this, and I will show them to you right now. So let's do this. Data frame 3 is equals to data frame, that's the original data frame, dot drop. We are dropping, suppose now, since we are working with columns, from this original data frame, I'd like to drop column 2. the entire column 2. So this is all we do. 2 comma axis is equals to 1. That's one way of doing it. So let's print data frame 3, and as you see there are columns 1, 3 and 4. 2 has been completely removed. Okay, that's one way. So the next way is actually similar, but just there's a difference in the way you provide your argument to the axis parameter. So data frame dot drop, and since we are working with the exact same scenario, instead of just providing 2, let me show you how you can drop multiple columns from your data frame. So let's suppose we'd like to drop 2 and 4. I'm doing axis is equals to, instead of doing axis is equals to 1, I can do axis is equals to columns. Okay, that's what I can do. Now, okay, so I actually need to change this from 3 to 4, and as you guys will see, columns 2 and columns 4 have been dropped, and hence I am only shown column 1 and column 3. So it is super interesting stuff for you to know. Now you see, what I should mention to you, right, is that you just saw, to create a new data frame that stores the queried form of our original data frame, we have been creating a new data frame object and storing the contents of the queried one inside of that. Now there is a way for you to combat this, right? So just to show you guys, you can see what the original data frame looks like. This is the original data frame. Now if you'd like to make changes to the original data frame, all you'd have to do is object dot drop, and we'll do, suppose I am dropping here maybe let's take out a column 4, so 4, and we'll do axis is equals to 1, and this is the keyword you need to keep in mind. The name of the parameter is in place, as you can see here. So let me just go back there and see, in place is equals to false. It's defaulted to false, meaning that the original data frame is not being changed in any way whatsoever. Okay, but if you want the original data frame to get changed, then all you do is set in place to a value of true. Now when I print the data frame, remember guys, we are not doing now such way data frame 5 is equals to and so on. What we are doing is data frame, that's the original data frame, dot drop, and in place is equals to true. Now when I print the original data frame, you guys are going to see that 4 has been completely removed, and this is the new state of the former data frame that we were working with. From this, it now becomes this. Okay, so if I set in place is equals to false, you guys are going to see nothing happens to the data frame itself, because we are not modifying the original data frame in any way whatsoever. Okay, this is kind of an instantaneous kind of operation, and it does not change the original data frame in RAM. Hence, when we print the original data frame, despite dropping, in place is set to false, so the data frame remains unchanged when printed to the console. So you'll notice I am kind of emphasizing on this specific kind of operation just because I want to make sure that you guys understand the concept of in place is equals to true and in place is equals to false. So that is that for the concept of dropping elements or values according to certain axes. Now, there is one more thing that I'd like to discuss for this specific tutorial, or for this video rather. It is the concept of indexing, selection, and filtering. Okay, this is really interesting because this enables us to have a much higher level of, I would say, conditioning to our data frame's contents. Basically, it's going to allow you to really take your querying capabilities to the next level. The concept of indexing, selection, and filtering, right? Now, you see, it is very similar to the concept of how we used to apply conditionals and filtering to our NumPy arrays, but it's just that now you are applying it using pandas methods. Okay, so let me demonstrate. Go ahead, guys, import pandas as well as NumPy. So pandas as PD, NumPy as NP. Now what I'd like us to do is create an object. You can call yours anything you like. I'll do obj is equals to pd.series numpy.arange. Within this, let's make it a small series, just pass 4. Now the index to be given to these rows shall be A, B, C, and last but not least, D. If you'd like to view how this object looks, you can go ahead, print it out to the screen. It's a small series, nothing that much interesting there. But now, just to touch on a few things, right? You guys know series, we can index, we can select, we can filter. How? Let me show you. So obj, and I can pass the name of any of the values in the indexer column to retrieve the row itself. You guys know we did do this in a previous video. So for example, obja returns to me 0. If I do, let's copy paste this, objc, I get 2. Now, in case you are wondering, what if I do an index that does not exist? This is what we obtain, a key error. Okay, so that is fine. Let me comment these out. Now, that's basically how we index. What we just witnessed was the concept of indexing. Okay, so that's fine. Now what you can do as well, this is probably something you may see for the first time. I don't think I showed you this before, but anyway, you can use numbers themselves. Okay, by numbers I mean the position of the row. So obj, you guys know the first row is assigned 0, second is 1, 2, 3, and so on. Python is 0 indexed. So as you see, obj1 returns the, logically speaking, the second row, because obj0 is the first row. So the second row in our series is B, which has a value of 1, which explains why the value of 1 was returned to our screen. Now, with regards to indexing and, slicing and so on, by selection, we really mean slicing. So let me add this in a bracket here, slicing. Now, slicing is an operation that is super easy to do. All you need to do is provide a start and a stop index. Now, what we can do is using the numerical indices. The numerical indices are assigned to the series and the data frame objects by default. So there's nothing much that we have to do with that regards. So all we need to do is really just focus where you'd like to start and stop the slicing operation. So let me demonstrate for this. 2, 4 tells us now that I am going to obtain from value 2 up till value 4, excluding value 4. So I'm only going to obtain elements 2 and 3. So this is 0, that is 1, that is 2, and that is 3. So only C and D. Let us see how correct we are. As we see, so we only see C and D. So that is good. Now, there are several other ways you can slice. What we just did was using the implicit numerical indices that are provided to series and data frame objects by default by pandas. We can use these explicit indices when it comes to slicing the data frame. Now this is less of slicing and more of fancy indexing. So instead of using the numericals, we are using the concept of fancy indexing, where we provide multiple indices that we would like to retrieve from the series object. So let me demonstrate for you. I'll comment this out there. So here we have, let me move this comment here. Yeah, so here print obj, and in a square brackets, in a two-dimensional array, what we are doing is passing the name of the, or the value of the index itself. So we have the following 4 indices to choose from: A, B, C, and D. So let's proceed to play around with this. Let's do A and C and just see what it turns out to be. So we should get 0 and 2. And as you guys see, that is exactly what we get, the entire row. So that is fine. Now, if you are wondering, you can also fancy index using the implicit numericals that are assigned to the data frame and series by default. So we want A and C. A has the implicit value of 0, and then B is 1, C is 2. So 0 and 2. Let us see how this works out. So 0 and 2. As you guys see, we get exactly the same results. The preference, it's all up to you, whatever you are comfortable with using. However, you should know that certain situations may require that you use one technique over the other. So that's fine. Now, what I'd like to show you is how we have the ability to filter. Filtering the series or data frame is nothing difficult. We've covered that in detail during our NumPy tutorial series on the channel, and it's exactly the same. Okay, it's exactly the same logic in which we can use our comparison operators in Python and so on. To demonstrate this, let me pull up obj again. This is what obj looks like. And suppose now I am printing obj, but I want all the values from obj that are less than 2. So essentially we'll only get returned with A and B. Is 0 less than 2? Yes, this will return to us. Is 1 less than 2? Yes, that will get returned to us. Is 2 less than 2? No. So from C and D, it's not going to show up. To give you guys the answer, this is what we obtain, A and B. That is the concept of filtering, using Boolean indexing and so on. So those are Boolean conditionals, comparison operators. Now, that's fine. I would like to show you now how slicing with the indices themselves is possible. So what we just worked with early on was the concept of fancy indexing. Here, we did that here, fancy indexing, and we also did slicing operations. Now, I want to show you guys how you have the ability to actually slice using the labels themselves. So let me show you guys this. This is an interesting one. So obj, and I'm slicing. I want to slice from A up until C. Now, take a moment to think about what do you think is going to get returned to us. So obj, this is obj. We are slicing from the indices A to C. Do you think we are going to get 3 or 2 values? That's my question to you. 3 or 2. Okay, so I'm going to run this and you are going to compare your answer now with what I am about to tell you. It is likely something you are seeing for the first time. So notice guys, we get 3 values returned. This is because, let me comment this, when you attempt to slice with the indexer column, the start and the stop index are inclusive in the range. Okay, so that is important to take note of. Now, that is fine. Now, the reason as to why you should know about this is because this is also one of those techniques that can actually be used to modify the series or data frame that you are working with. So just to give you a bit of insight, right? obj, that's obj in the default form. Now, what I'd like to do is I'd like to just attempt to insert a bit of information or values to a certain portion of the data frame. So I'm doing obj from, let's do A up until C. I am setting those values to be 5. So basically it will be 5, 5, 5, and 3. D is not included in this slice. Okay, it's only A, B, and C. Now you guys are going to see when I print object to the screen, this is what I obtain. I get 5, 1, 5, and 3. Okay, guys, so I actually made a mistake here. Instead of using a colon, I don't know if you saw that, I used a comma, but you guys, that was going to be the next thing I show you, how you can prevent the entire slice from being populated. So I will go over that again. Anyway, this is what we obtain. This is using the slicing technique. Okay, but if you don't want to use the slicing technique, suppose now you only wanted A and C to be filled with the value of 5. There's several ways to do that. You can just, manually change each one. I don't know why you do that, because it's not very, I would say, convenient. Your alternate way would be to actually utilize the comma. So the comma gives you distinct values that you can slice with. Now, I'm just trying this for our purposes. What if we use so basically a 2D array? As you guys can see, it is exactly the same. The correct way to actually provide multiple indices to be changed is using a two-dimensional array. So here you see I included D, and D indeed got changed to 5. So that's what we have there. Now you guys are probably wondering about the exact same operations but on a data frame. So I'd like to show you guys a few of these operations when performed on a data frame. So import numpy as np. Next, let's do a data frame is equals to pd.data frame. Within this numpy.a range, I'll do 16. Oh, let's reshape this. Reshape to 4 by 4. And here for the index, let's do an array. First Ohio. Next we shall do Colorado. Next I'd like to do Utah. Last but not least, New York. Okay, now it is time to set columns. Columns is equals to, let's keep this simple, 1, 2, 3, and 4. So we have a 4 by 4 data frame. You guys can copy paste the previous one we worked with, right? That should not be an issue. Anyway, that is what we have now. Now let me show you how we have the ability to index, slice, and filter, but on a data frame. So this is our simple indexing technique. Let us index the row, or the column rather, column 2. Let's index column 2. So I'll do the name of the data frame in square brackets, the name of the column. And as you guys will see, these are the values for column 2. 1, 5, 9, and 13. And this is exactly what we obtain. So that's fine. Now let me comment that out. Let me show you guys how you can return multiple columns from the data frame. Print data frame in a two-dimensional array. I'd like you to pass the names of the columns that you'd like to return. Suppose I would like to receive column 1 and column 3. So let's go ahead and do that. Column 1, column 3. Okay, so I spelled 3 incorrect, but here you have it. Now, this is something I want you guys to actually see. Go ahead, pass in 3 and 1, and notice the order of the output. Basically, what I'm trying to get at here, guys, is that the order in which you call or return the columns is the order in which they will be shown to you. Okay, so that's a very good trick and tip to know. So that's fine. What we did here was so here is what we call indexing operation. Here is what we call fancy indexing operation. It's where we pass multiple values to get returned, or multiple indices to get returned multiple values. That is fine. Now, you have the ability to slice or select data using the numericals as well. So let me show you how this works. Print data frame in a square bracket, all rows up until 2. So all rows up until 2 exclusive of index 2. So Ohio is index 0, it's going to be included. Colorado is index 1, it's going to be included. Utah is index 2, it is not going to be included. So is New York, because the stop value is actually, it's not 2, it's 1. So 0, 1. It stops at Colorado. This tells us that only Ohio and Colorado are going to be returned to us, which is as we see. Now this operation is known as slicing operation using the implicit index. Okay, the implicit index. So that is fine. Now, what I'd like to show you as well is how you have the ability to actually filter. You can filter your data frame. Let me show you. So just to pull up the original data frame for you, print data frame, let's run this. That's the original data frame we see. Now, how can I filter this data frame? So let me show you. Let's do data frame, where all values are less than or equals to 10. Now when I run this, you guys are going to see we return or obtain only those values that are less than or equals to 10. The entire data frame is shown, but only those values that we want to see are shown to us in the data frame. The rest of the values get populated with an NaN. Now, this is one way of filtering. You can be much more fancier in a sense where you can base your output on one column. So you can return all rows of values, but you can base what is being returned of one column. So let me show you how this works, right? Just to pull up the original data frame for us. That's the original data frame. It's this one here. It's that there. Now, let me show you what I mean. So I want to return the columns. I want to return basically all I want to return all rows, but only if the value in column 3 is greater than 5. So let me show you how we'll do this. We'll do data frame, the column which is 3, and we'll do greater than 5. It's a simple syntax, guys. Do not get confused by this syntax. Now, when I run this, you're going to see that based in column 3 is 6 greater than 5. Yes, it is. So the entire Colorado row will get returned to us. Is 10 greater than 5? Yes, it is. So Utah will get returned to us. New York is the same. Is Ohio, but now 2, is 2 greater than 5? No. This tells us that the row for Ohio is not going to get returned to us because it does not meet the criteria for the filtering process. Okay, this tells us we're going to get outputted with only 3 rows: Colorado, Utah, and New York. So when I run this, it is exactly as we have just discussed. So that's what we see there. Now, you can even do this operation using simple Boolean. So Boolean conditioning. Now, this is where the data frame itself is returned to us, but with Boolean values in it that tells us what values meet the condition and which values don't meet the condition. Okay, so let me show you this. Now, what I'll do is pull up data frame again for you. So this is the original data frame, and we are checking if each value in the data frame is less than 5. If it is less than 5, a true will be placed there, otherwise a false. So basically for the first row, we expect to see all trues. For the second row, 4 is less than 5, that will be true, and we'll see 3 falses. So enough discussion, I run this, and this is exactly what we observe. So if you want to see the exact values that was in the data frame itself, what you'll do is data frame, and the condition that we are working with. Let me comment this, and it is exactly as we expected. Okay, data frame less than 5. The only values that were less than 5 in our data frame was 0, 1, 2, 3, and 4. And if you compare it to the Boolean data frame that we obtained, the trues match up with the values that we see. So it is interesting stuff there. Now, okay guys, so now I would like to show you how you can use the concept of Boolean conditioning and Boolean conditioning to impute values into the data frame. Now this is an easy concept. So essentially what I'd like to do is data frame. I want to show you guys the original data frame that we are working with. This is it. Now next what I'd like to do is I want to set data frame less than 5. So it's exactly as we saw above. I am just replicating the logic to show you how the process works. Okay, so now I just want to print data frame less than 5, and we obtain this. And last but not least, it is time for the actual operation. So in a new line, I am doing data frame less than 5 is equals to 0. What this means is that wherever the data frame's value is less than 5, it will be filled with a value of 0. Now this value can be anything you like, right? It is up to you. So you can make it yes, no, you can make it A, B, C, D, E, and so on. So let's keep ours a bit boring. Let's make it yes. And now I am going to print the data frame to the screen, and as you see, it is filled with yeses. So that's what we have. You guys can fill this with zeros as well. So that's what we obtain there. Now that is interesting stuff. That's how we filter and impute values into the data frame. So that's good. Now what I'd like to demonstrate for you guys is the concept of selection of values from the data frame. Now let me pull up the data frame to the screen. So I'm going to take away this. I'm commenting that out. And yes, this is the original data frame we were working with. And now we are going to attempt to see selection of values from the data frame itself. So let me do this. What I'd like to do now is basically using the same data frame. We have our data frame here. I will move this print statement down. So that's the data frame we are working with. Now we are going to be introduced to LOC and ILOC. If you are wondering, right, LOC stands for location, and ILOC, there is some sort of variance with regards to this, but what it stands for is indexer location or integer location. Okay, it's depending on what you want to use, but basically these are special operators that are included in Pandas package, and they help us to select subsets of rows and columns from the data frame. Okay, now let me demonstrate for you in a simple example, since this is the first example we are using on a data frame. So data frame dot lock, and in square brackets I can pass Colorado, comma 2, comma 3. Now pay attention to this, guys. As you can see, this is the data frame we have. I am returning the row, which is Colorado, and I'm returning the column values for those for Colorado row, which is 2 and 3, telling me that I'm only going to get outputted with 5 and 6. So I run this, and as you guys see, I get 5, I get 6. First comes row, then comes the columns that you'd like to retrieve. So let me type this here: lock arguments in the order of row, column. So I will add it here in plural form because you guys can see it is possible to return in multiple. So basically multiple rows or columns. So that's fine. Now what we can do as well is using ilock. Now this is where the differentiator arises, and it's going to make a lot of sense to you. You see, lock is used to index the data frame using the explicit index values. Explicit index values. Explicit index values are what? It is referring to the header row and the indexer column. Now ilock, that is why it is called integer location, because of the fact that, you see, ilock is used to index the data frame using the implicit numerical index values. By numerical index values, I mean, you guys know, this is a data structure. By default, Python assigns numbers, index positions to each row, each column, and so on. So Ohio is assigned 0, Colorado 1, Utah 2, New York 3, and so on and so forth. That is why lock is used to index the data or query the data frame using the explicit index values, and ilock uses the implicit numerical index values. I will demonstrate this for you. So print data frame dot ilock, and within this the arguments are the same, row and then column. Suppose I want row 2. What is row 2? Ohio is 1 or 0, Colorado is 1, Utah is 2. So we are indexing row 2, which is Utah, and the elements that I want from this row is basically the columns. So column 1 is 0, column 2 is 1, 3 is 2, 4 is 3. That's using the implicit index that is given to the data frame by Python or Pandas itself. So for row 2, 0, 1, 2, that's Colorado. Suppose I would like to return the values. So 0, 1, 2, that's Utah, my bad, Utah. Let's say we want, so that's 0, 1. I want 1 and 3. That's column 2 and column 4. That's 1 and 3. As you guys are going to see, 1, 3. When I run this, you are going to see that for the row, which is Utah, we are returning the values from column 1 and 3. So that's going to be 9 and 11. As you guys see, that is exactly what we obtain. Now I should mention, guys, the only way you can get good, in inverted commas, with pandas, and especially with these operations, is to keep practicing it. Okay, the only way you become comfortable with using the lock and ilock indexer methods is to actually do more hands-on practical than examples. That's going to basically, you know, keep testing your knowledge, and eventually you get comfortable to using it. So that's fine. Now what I'd like to show you as well, dataframe.ilock. So I'll comment that out. I want to show you guys what happens when you just pass one value to it. So suppose I am doing 2. Now when I run this, as you guys are seeing, the name of the record that has just been returned to us is Utah. This tells us that, I mean, it follows the exact same arguments as the lock. Arguments in the order of row, comma, column. Right? Now this tells you that if you only pass one value or one argument to the ilock indexer method, it is basically implicitly just assuming, you know what, this number is representing the row that the individual would like to return. So ilock2 gives us the row which is 0, 1, 2. That's the whole row for Utah. That is why the name down below here shows Utah. So I hope that makes sense to you. That is fine. Now I just want to show you guys one more thing. So dataframe.ilock. These indexer methods are very, very powerful. Suppose I want to return multiple rows from my data frame. I want to return row 1 and row 2. You may ask, what is row 1 and row 2? So let's pull up the data frame. row 1, row 2. So that's 0. There's 1, Colorado and Utah. That tells me I am expecting to return or retrieve the rows which are Colorado and Utah. So as you guys see, that is exactly what we obtained. Now let's take this one step further. Within the iloc indexer method, we are providing now the columns that we'd like to return. So at the moment, we are getting all 4 columns, okay, for both rows. Now suppose we'd like to narrow this down a bit. Suppose we'd like to work with the columns maybe so this is 0, 1, 2 and 3. Now let's go for 0, 2 and 3. 0, 2 and 3. 0, 2 and 3. We are skipping column 2. So what we can expect to see is Colorado, Utah, 1, 3 and 4. Let's go ahead and run this. And as you guys see, Colorado, Utah, 1, 3 and 4. So I hope you guys are finding this interesting, and most importantly, I hope it's making sense to you. Okay, now let me show you even more. So print data frame dot lock. Once you see the lock indexer method, automatically you should know that we are using and we have to use the explicit indexes. That means the header row and the indexer column. Okay, so let's do, I want all rows up until Utah. Okay, so that tells me I am going to see Ohio, Colorado, as well as Utah. You guys should know from the series example that when you are slicing using the explicit indices, it is inclusive of the stop index. So that's my rows portion, all rows up until Utah, comma. What columns would you like? So suppose just for this example, I would just like to have column 2. So I pass it here, TWO. If I run this, as you guys see, that is exactly what we obtain. I stopped at Utah, column 2. I am returned with 1, 5 and 9. And that is exactly what we see down below. So that is excellent. Now, let me show you something even much more complex. Okay, so let me comment this out. I will create a bit of space here. Now, print. Let me move this up. Print data frame dot iloc. Within the iloc, I want all rows. I want all columns up till column 3. Let me run this. Let me show you exactly what we obtain. Now, that is exactly what we were expecting. Remember, using the implicit, the numerical indices, it is exclusive of the stop index. So that is why we, just to pull up the original data frame for you, the columns we wanted was from 0 up till 3. So 0, 1, 2, 3. Column 4 is excluded. So that is explaining why we only returned 1, 2 and 3. Now, to take this one step further, right, what I want to show you is that based on the output, this is the output we just obtained, I can actually do slicing and indexing operations on that output itself. And let me show you exactly how this is done. So what I'll do is, as part of this, remember guys, what we obtain here is a data frame. It's still a data frame, which means I can slice more on this, I can index more on this, I can do Boolean conditioning and so on, all on this little data frame here. So let me take this one step further to show you guys what I mean. Now, data frame dot 3 is greater than 5. And as you guys are going to see, we have narrowed the data frame down one step further. Why? What did we do? So this is the data frame we had. Then we added another condition to this, which stated data frame dot 3. Data frame dot 3 is alluding or referring to column 3. As you see, we say greater than 5. This means that only if the value in column 3 for that row is greater than 5, then the contents of those rows will be returned to the user. In our case, Ohio did not match the criteria, therefore Ohio has been removed from the output. So I hope this is making sense to you. Now, to be honest with you guys, we have covered a good amount of work in this video. This is one of the most intense videos that I have recorded for the channel, which is great. And yeah, I am ready to conclude this video at this point. In the next video, we are taking it further with exploring more concepts pertaining to Pandas series and data frame objects. So with that, thanks for your time, guys. Thanks for watching. Thanks for staying till the end of the video. I hope that you are finding these sessions interesting and informative. Yeah, thanks guys. Thanks for your time. I will see you in the next YouTube video. Good luck with your work.